Welcome to the Yaka Digital Network videos. If you have ever stood by the banks of the Victoria Nile, you are witnessing the movement of millions of gallons of water every hour. To geographers, this is drainage, the physical way water moves across a landscape through a network of rivers, lakes, and wetlands. East Africa holds some of the most significant water resources on the continent. But why does the water pool where it does? Why is the Nile forced into its specific northbound path? And why are some lakes shallow while others are deep enough to swallow mountains? The location of these features follows a distinct structural logic. Instead of being scattered by chance, these lakes and rivers occupy specific basins carved by a long history of tectonic activity. By examining the geological architecture of the region, we can map how the movement of the Earth's crust dictates our economic survival today, and why modern interference in these systems is reaching a dangerous tipping point. The first major geological force we must examine is tectonic downwarping. Millions of years ago, the land positioned between the western and eastern branches of the Rift Valley warped downward. This created a broad, saucer-like depression in the landscape. Because Lake Victoria was formed by this gradual sagging, it is vast in surface area, but relatively shallow. As this scale shows, its maximum depth is only about 80 meters, comparable to the height of a small hill. We see the physical result of this process on the ground today. The shallow basin allows for flat, expansive shorelines spreading across the surrounding plains. This combination of massive surface area and shallow depth results in high rates of evaporation. This water vapor acts as an atmospheric engine, driving the rainfall patterns for the entire Lake Victoria basin. The Western Rift Valley was shaped by a very different force, tectonic faulting. Here, the Earth's crust cracked under tension. As these fault lines opened, a central block of the crust dropped vertically, creating a deep, narrow trench with vertical sides. The landscape confirms this process. Lakes like Albert and Tanganyika are bordered by these steep, rocky fault scarps, where land falls sharply into the water. Smaller basins like Lake Bunyoni were formed through volcanicity. In these cases, lava flows or volcanic debris physically dammed up a valley, creating deep and highly scenic lakes nestled between hills. These origins dictate the chemistry of the water. Because faulted and volcanic lakes are deep and steep-sided, they often have low oxygen levels at the bottom and a higher concentration of minerals compared to shallow, down-warped basins. Beyond these basins, the drainage of East Africa is defined by the Nile River system, the primary artery of the region's water network. The Nile follows a specific topographical path, beginning in the highlands of Rwanda and Burundi, feeding into Lake Victoria, exiting at Jinja, flowing through the swampy basin of Lake Kyoga, and dropping into the Rift Valley. Human economic activity is mapped directly onto these physical features. The calm, shallow waters of our basins provide aquatic resources needed for large-scale commercial fishing. Generating hydroelectric power requires a change in relief. Engineers look for places where the river drops violently over hard, crystalline rock to harvest kinetic energy. This is why massive dams like Nalubale and Karuma are built at specific geological drop-off points. They are positioned where the slope provides maximum power. We see the most extreme relief change at Murchison Falls. Here, the river is forced through a narrow gap before making a violent drop into the floor of the Rift Valley. From energy and transport to food and water supply, the economic life of Uganda is precisely fitted to these tectonic anomalies and drainage patterns. Look at a map of a Rift Valley lake like Lake George. You will notice rivers flowing into the lake, but no major river flowing out. If water enters the basin but never leaves through a river, what happens to the water level during the dry season? And more importantly, why does the water eventually become saline or salty? During the dry season, intense evaporation removes the water from the basin. This causes the water level to drop significantly, leaving behind the minerals and salts that were eroded from the rocks. Over thousands of years, these minerals accumulate. Since only the pure water evaporates, the remaining basin becomes increasingly concentrated with salt, creating a saline environment. This geological understanding is now essential for managing a modern crisis: the rapid destruction of East African wetlands for urban expansion. A wetland is a complex physical system. It consists of dense vegetation, like papyrus, rooted in thick, highly retentive alluvial soils. These areas serve as the drainage system's safety valve. Wetlands act as nature's sponges, absorbing massive amounts of rain and releasing it slowly to prevent sudden surges in river levels. In cities like Kampala, the natural sponge is being removed. Swamps are being drained and paved over with concrete and factories, leaving the rain with nowhere to soak in. When you remove a wetland, you lose its mechanical service. Without the sponge, the water stays on the surface, causing devastating flash floods. It proves that the flood control provided by a swamp is far more valuable than the land built on top of it. East Africa's vast lakes and the flow of the Nile are the direct physical results of millions of years of crustal movement, physical foundations that today generate the region's power, provide our food, and facilitate our trade. You can watch more videos for all classes here and get all content at www.yaka.cc.